Hey everyone! Have you ever written JavaScript code with setTimeout, promises, or event listeners and wondered, why does this run before that? Well, you're about to uncover the magic behind JavaScript's event loop. Think of JavaScript as a busy chef in a restaurant. It takes orders, prepares meals, and serves them. But some dishes take longer to cook, so the chef doesn't just stand there waiting. Instead, they multitask while making sure every order is served in the right order. And that's exactly how JavaScript works. Let's break it down step by step with an animated demo. JavaScript is a single-threaded language. This means it can only do one thing at a time inside the call stack. Let's start with a simple example. When this runs, you might expect it to print start, timeout, promise, end. But the actual output is start, end, promise, timeout. Why? Because of the event loop. Let's visualize step by step how JavaScript processes this code. Step 1. Call stack executes synchronous code. JavaScript starts executing the script line by line in the call stack. Console log start gets executed immediately. Then we hit setTimeout. JavaScript doesn't wait for the timer to finish. Instead, it moves the callback function, like console log timeout, to the web APIs to wait asynchronously. Next, we encounter promise.resolve. Promises are microtasks, and JavaScript immediately schedules them in the microtask queue. Finally, console log end runs because it's just another synchronous operation. At this point, the call stack is empty, so the event loop steps in. Step 2. Event loop checks the queues. The event loop constantly checks, is the call stack empty? If yes, it picks tasks from the microtask queue first, because microtasks have a higher priority than normal tasks. The microtask console.log promise runs first from the microtask queue. Now that the microtask queue is empty, JavaScript moves to the task queue where setTimeout was placed earlier. Finally, console log timeout is executed from the task queue. And that's why the final output is start, end, promise, timeout. Event loop priority. Microtasks versus macrotasks. Remember, JavaScript always processes microtasks before macrotasks. Microtasks promises, then catch, and finally. Next tick in Node.js. Macrotasks, also called tasks, set timeout, set interval, set immediate, Node.js, I/O callbacks, UI rendering. To summarize, synchronous code runs first, call stack. Microtasks, promises, run next. Macrotasks, set timeout, set interval, I/O tasks, run last. By mastering the event loop, you can write more efficient, non-blocking JavaScript code. I hope this explanation made sense. If it did, make sure to like, subscribe, and keep coding smart. And yeah, if you want to learn how hosting happens in JavaScript, then don't forget to check the video showing on the screen. See you there.